So in this video, we'll look at a general method to find the inverse of m by using row operations. And in the last video, we have looked at the meaning of inverse for 2 by 2 matrices already. And I provided you with a formula. But in this case, this method is more general because it works for all square matrices if the inverse exists. And let's look at the following. Basically, now the method is like this. In the first step, you have to put the square matrix M in the left-hand side, and the right-hand side is going to be another matrix of the same size as M, but it is identity matrix, so it's like identity. And you're asked to do lots of row operations to do some reductions on the numbers on the left-hand side, so that at the end, you are left with the identity matrix on the left-hand side. And of course, if you do the row operations, and the matrix on the right-hand side is changed, right? And whatever matrix you have here, it's gonna be the inverse we want. And this process is called the row operations to find the inverse of M. And let's look at a smaller case first. I give you a simple smaller matrix 2 by 2, which is like this for the given M. If you use the formula we have seen already, so I put the formula here again in the red color. It's gonna be the answer like this. So that's the inverse of the matrix. And so you know how to find the matrix inverse already. But let's look at our new method for this case. So we start with something like that. And please recall that in the final stage, I would like to see the matrix like this, which is the identity on the left-hand side. And let's do the typical step for the row operations. Usually we focus on the bottom left corner first. And to make it 0, we can do something like row 2 minus row 1, right? So in that case, the row 1 is unchanged, but the row 2 is going to be updated. So this number is going to be 0, and this one is 3 minus 2. It's like 3 minus 2 here because it's row 2 minus row 1 is going to be 1. And you see this spot is going to be row 2 minus row 1. So it means it's 0 minus 1, which is minus 1 now. And this spot is going to be row 2 minus row 1. So it's 1 minus 0, which is 1. And then you see, please compare what we want in the final stage to our current matrix on the left-hand side. We need to change it to 0 in the row 1 by using row 2, right? And the way to change is, I think, we can use row 1 minus 2 times row 2 now, because in that case we can get 2, which is in the row 1, minus 2 times 1, right? So we'll get 0 in that case. So it means I will leave the row 2 unchanged, but now I'm updating the row 1. The first number is unchanged because it is 0, so you're not changing anything when you do the row operations. And this number is going to be what we do here, right? It's going to be 0. And this number is gonna be row 1 minus 2 times row 2, which is minus 1 like this. So it's 1 plus 2, which is 3, right? And this number is gonna be what? It's gonna be row 1, which is 0, minus 2 times 1. 1 is here, so it's gonna be minus 2. So you see, I think at this stage, the process is finished because this one is already the identity, and I claim that this one is our current inverse for the given M. So let me write down the answer here. And as you can see, this method to find the inverse is the same as the matrix you can obtain by using the inverse formula. And let's do a slightly more complicated example. If I give you an 3 by 3 matrix, let's see whether you can do that. Please look at the current matrix, which is 3 by 3, and let me write it down on the left-hand side. And the right-hand side, you have to write down the identity like this. And can you see how to do the row operation? Let's do it one by one. And typically, we always start with the bottom left corner below the diagonal on the left-hand side. So let's try to reduce this 2 by 0 first. And usually we leave the first row unchanged. And the row 2, we have to make it 0. And what we can do is row 2 minus 2 times row 1, right? And we'll get 0 on the first spot on the second row. And the next number here is going to be what? It's going to be 5 minus 2 times 2 is 1. And this number is going to be 3 minus 2 times 3, right? So it's going to be minus 3. And this number is going to be what? It's going to be 0 minus 2 times 1. Because you have to do this, right? 0 minus 2 times 1. So it's going to be minus 2. And I think the remaining are going to be unchanged because you see the row 1, these two spots are zeros. And let's do row reduction for the row 3 because you see row 3 also has 1 same as what you have in the first column and the first row. So what we can do is row 3 directly minus row 1. So in that case, we'll get 0, and the remaining numbers are going to be like this. So I hope you can finish it yourself. Because, for example, this number is what? This number is row 3 minus row 1. It's like 0 minus 2, right? For example, this number is going to be 8 minus 3. So I think you can do it yourself. And the next one to reduce to be 0 is going to be this one. And after this process, at least we notice that the bottom left 3 spots are all zeros after this. So to make it 0, we can only use the row 2. Using row 1 doesn't make sense because row 1 has 1 in the first column. It will change our 0 here, which is not supposed to be changed anymore. So let's do it by the row 2. So I think the correct row operation is row 3 plus 2 times row 2 because you see it's like minus 2 in the row 3 spot. You have to do something like for the row 2 it is 1, so I think I have to make it plus 2, right? So it's going to be 0. And let's do the remaining spot here. For example, this number is what? This number is row 3, which is 5, plus 2 times minus 3, which is minus 1 altogether. And similarly, for the remaining spot, we have these numbers like this. For example, you get 2 because of this, and you get minus 5 because of this. So you have to check it yourself. And you see, the final stage is that we want the left-hand side be identity. So I think it makes sense that in the final row, we can just change the sign here. So for example, I can just assign by multiplying the whole last row by minus 1. So you see the first two rows will remain unchanged, but I need to change the sign by multiplying minus 1 to all the spots just on the last row. So now let's carry out the remaining process. I think it's kind of like the backward substitution, but now let's do it in the backward way in the sense that we try to make this one 0 by using row 3 because you see row 3 is done. Row 3 is totally done. It's the same as the last row of an identity matrix. So now we have to make this 0 first. Then the remaining step, we can take a look at the remaining two, right? So now you see row 2 with the row 3, and row 2 it has minus 3 now. So row 3 has 1 on this column. So to make it 0, I think what we need is row 2 plus 3 times row 3, right? And so it means the correct one for the update of the row 2 is going to be row 2 plus 3 times row 3. So let's do it together. I think the first two spots are not changing because you see both are 0 now for the row 3, right? And as we note here, this one is for the spot here. And for the remaining three numbers, they are going to be 13, minus 5, and minus 3 respectively. Please look at my calculation here and check yourself. And then the next one, we can actually make this spot on this column for the first row 0 by using row 3. And I think the correct one is row 1 minus 3 times row 3, right? Because in that case, we'll get this spot 0 like this. So let me do the arithmetics here. You see the first two spots are unchanged because of the fact that these two numbers in the row 3 are 0. So by using this row operation, you're not changing the numbers. And let me write down the remaining 3 entries. So please check my calculation here. These are 3 equations represent the 3 entries here. So you can check it yourself. And you see up to this stage, we're almost done. This one looks very much like the identity matrix except this one. And to make these two zeros, we can only use row 2, right? Because row 3 spot is 0. So you cannot change this spot of the row 1 by using row 3. So let me do the remaining steps now. So you see, as we have noted, we can only use row 2 to change the row 1 now. And I think it's quite obvious we can use row 1 minus 2 times row 2, right? So I write it down here. And for the row 1 based on this, and as we noted, this equation basically implies this one is 0, and of course these two entries are not changed because you see on the row 2 these two entries are zeros. And let me do the remaining entries now. So you see for the last 3 entries on the first row, it basically follows from this arithmetics, and you can check my calculation is actually correct. And let me write the final answer down because we are left with the left hand side to be identity. That's what we want. And this one is the inverse of our original matrix. Let me write the answer down. See, for the given matrix here, we get to the final stage. The inverse of M is going to be this matrix. And if you're not convinced this one is correct, or maybe you're worrying that maybe I've done some wrong calculation in the middle, you can easily check your answer is correct just by verifying these two equations are actually correct. And please do the matrix multiplication yourself for the left hand side. Surprisingly, you'll get the identity on the right hand side for both ones, and it gives you a sense that our calculation is actually correct for this m. And let me make a final note here. The first note is that it's something you have to recall. Not all the matrices are invertible, which means that sometimes the inverse does not exist. So if we use this row operation process to try to get the inverse for a matrix which is not invertible, can you imagine what's happening? So to put it simply, I give you a matrix 1, 2, and 2, 4 in the first row and the second row respectively. And please recall the fact that we can check AD minus BC to check whether it is an invertible matrix. And AD is like this, so it's like 4 minus BC, like this, 2 by 2. So which means it is 0. And if you recall it, when AD minus BC is 0, we understand that it is not an invertible matrix. So which means M inverse does not exist. So let's see what's happening if you are keen on finding the M inverse by our row operation method. Let's look at the way we usually do to make it 0. We can use row 2 minus 2 times row 1. And in that case, what you get is 0, 0, minus 2, and 1. And now, please look at what you have. You see the row 2, both spots are totally 0. So what does it mean? It means no matter what you do on the row operations, you cannot change this spot to 0. And you cannot make it 1 easily without changing this one. So let me put it here. There's no chance we can make the final stage, which is the left-hand side, is going to be an identity matrix, right? Because whenever we have a 0 rows, like this case, going to do it. So please try yourself. No matter what row operation you do, you are not going to arrive at it whenever you have a 0 rows. And that's note 1. And let's look at the second note. Now I claim that to find the inverse of a diagonal matrix, which means you have the zeros of the diagonal. It's actually a very easy process. Can you see why? I can just claim that the M inverse is going to be like this because if you recall the multiplication for diagonal matrices, you'll see what I mean. So as a simple example, if you multiply these two matrices together, because for the diagonal matrices, we can simply do this one. And of course, this one is an identity matrix, right? So it gives you a sense that this one should be correct. And that's the end of this video.